Hey everyone. Today we're going to be graphing inequalities and in particular systems of inequalities. But let's start off with some review of graphing inequalities in two variables like y is greater than or equal to negative 2x, negative 2x plus 8. Okay, so when I look at this, I think, oh, well, that's just this linear equation, y equals negative 2x plus 8. And so I think about plotting the y-intercept and then using slope to find another point. So if I started by graphing the equality version, I would have something that looks like this. 8 down 2 over 1, down 2 over 1. And so I'd have a line that looks like this. That's if I'm graphing the equality version. Well, the second thing I want to think about is, what about this inequality symbol? Well, when I see greater than or equal to, less than or equal to, that means I have a solid line. But if I had greater than or less than or even not equal to, I would have a dashed or dotted line. And we can do one of those next. Okay? And the third thing I need to figure out when I graph an inequality is which side of that line to shade. Now I can shade either above the line or below the line. Remember, the shading represents all the possible solutions. So where do they live? Well, I'm not sure, and some people like to go off the direction of the inequality. I do not, because sometimes that can be misleading, and a wicked test writer could actually make a problem where people thought that it was going to be one way and the reality was completely different. I like testing a point, and I think an easy point to test is 0, 0. The only time I can't use 0, 0 as a test point is if the inequality passes, the line passes through the point 0, 0. Here we don't pass through 0, 0, so I'm going to use 0, 0 as a test point. And we want to plug this 0, 0 into the original inequality. So what would that look like? 0 is greater than negative 2 times 0 plus 8, or 0 is greater than or equal to 8. Is that a true statement? Is 0 greater than or equal to 8? No, it isn't. So this is not a solution, which means no points on this side of the line will be solutions, and all the solutions will live on the other side of the line. So there's our first inequality. Y is greater than or equal to negative 2x plus 8. Remember, we started by graphing the equation version of the problem, something we practiced a lot in chapter 1. And then we looked to see whether we should have a solid or a dotted line. I guess we could add could be equal to for solid line. And then finally, we determined which side of the line we should shade by plugging in a test point. I like using 0, 0, and the only time I can't use 0, 0 is if the inequality passes through 0, 0 itself. Okay, let's take a look at our next one. We still haven't gotten to systems. We're just looking at single inequalities, not systems of inequalities yet. So how about y is greater than x squared minus 3x minus 4. So here we have a parabola, and we're wondering how to graph this parabola. Well, start with the equation version, x squared minus 3x minus 4. And I noticed that this factor is pretty easy, even though it's in standard form, and I could use minus b over 2a. I'd have a fraction to plug in, and I don't really want to plug a fraction in. So I'm going to factor this with x minus 4 and x plus 1. And I'm going to notice then that my x-intercepts, if I plug y equal to 0, my x-intercepts would be at positive 4 and negative 1. So I have some x-intercepts. I also have a y-intercept, and I know that this parabola points up. Okay, so let's graph what we know. Negative 1, 4, and negative 4 is the y-intercept. Now, halfway in between negative 1 and 4, which turns out to be negative 1.5, is our vertex. I'm not going to be so worried about that because I've got 3 points here. What about the shading? If I draw in this parabola, I'm sorry, not the shading, should I have a solid or dotted line? And I think the answer to that is, based on our inequality, we're going to have a dotted line. And now finally, which side of that parabola do we shade? Do we shade on the outside of the parabola, or do we shade in the interior of the parabola? Well, let's plug in 0, 0, and see. Remember, we're plugging into our original inequality. Y is greater than x squared minus 3x minus 4. And if I plug in 0, 0, I get 0 is bigger than negative 4. Is that true? Is this a solution point? Well, 0 is bigger than negative 4. And so anything in the interior of the parabola would be a solution. Okay? There's my solution to this inequality. Y is greater than x squared minus 3x minus 4. Fabulous. Well, let's take it a step further. And let's ask about this one. 9 is less than x minus 1 squared plus y minus 2 squared. What's that? Well, hopefully you remember that this is the equation of the circle. X minus h squared plus y minus k squared equals r squared. We can see that our radius is 3, and we can see that hk, the center of the circle, is located at 1, 2. So if I start by graphing the center at 1, 2, and I go down 3 and right 3 and up 3 and left 3, I'll have a circle. Because of the inequality symbol, I know it's supposed to be a dashed or dotted circle. Pardon while mine looks a little football-like. There we go. And now, what about the ordered pair? Well, I don't believe I passed through 0, 0, so I'm going to use that as a test point. And I'm going to have 9 is greater than 0 minus 1 squared plus 0 minus 2 squared. What does that give me? 9 is less than 1 plus 4. Is 9 less than 5? No. So this is not a solution on the inside of the circle, which means all my solutions must be out here on the outside of the circle. Ooh, it's a sun. Hi, sun. All right, so there's our third inequality. Now I think it's time for us to look at graphing systems of inequalities. And I have some problems that I'd like to look at with you, both going forwards and going backwards. So let's see what they look like. The first one, basic Algebra 1 type problem. Number 1, 3x plus y is less than 3. 4 minus y is less than or equal to 2x. There's my system of inequalities. Okay, so we need to graph each one. I actually want to start with this bottom one first because it looks harder to me. I know you're saying, but the top one looks harder because the x's and y's are on the same side. All right, we'll start with the top one. But really, I think the bottom one looks harder. All right, so here we go. 3x plus y is less than 3. And the first thing we're going to do is change this to an equal sign, and then how to graph from here. Well, I thought this was an easy one to do because I don't want to graph with y-intercept and slope. I want to graph with x and y-intercepts. If I plug a 0 in for x, I get y equals 3. And so look, I have this ordered pair 0, 3. If I plug a 0 in for y, this will go away. I'll have 3x equals 3, or x equals 1. And so that's my x-intercept. Now that doesn't mean I can't subtract 3x from both sides and have y equals negative 3x plus 3. Instead, it's I now have the same y-intercept that we found over here, but I could use my slope of going down 3 and over 1. So I like using intercept form when I'm given intercept form, which is standard form, and I like using slope and y-intercept when I'm given that. But in this one, I'm not given either. So I think what I want to do is I want to add y to both sides. And so my new inequality would be 4 is less than or equal to 2x plus y. And I'm going to graph the equation version of this, 2x plus y. And so when I find the x and y intercepts, remember, I plug in a 0 for x to find a y-intercept. In this case, that's 4. And I plug in a 0 for y to find that 2x equals 4, or x equals 2 is my x-intercept. So if I graph 1, 2, 3, 4, 1, 2, I get 1, 0, and 0, 3. And that's a dotted line. And on what side of that line do I shade? Well, if I plug in 0, 0, is 0 less than 3? Why, yes, it is. So I shade on this side of the line. Now, let's graph the other inequality in another color. Okay, we're plotting the point 0, 4. And we're plotting the point 2, 0. Whoa, wait a minute. And that's a solid line. Huh. Well, so which side of that line do I shade? Well, if I plug in a 0, 0, I get 0, 0, 0 is greater than or equal to 4. Well, that's not a solution. And so this time, we shade in this direction. Uh-oh, where's the overlap? It's hard to see any. Is it that they don't overlap? Well, if these lines were parallel, that would be true. But let's see if there's a point of intersection between the two lines. Remember, one of our lines was 3x plus y equals 3, and the other line was y plus 2x equals 4. If I subtract one equation from the other, I get x equals negative 1. I wonder what the y value is. Well, so 3 times negative 1 plus y equals 3. When I plug this into the first equation, I get negative 3 plus y equals 3, or y equals 6. Oh my gosh, it's not even on my graph. I thought there was no solution here. All right, let's remake the graph, because we know that these intersect. So 1, 2, 3, 4, 5, 6, 7. 1, 2. Let's graph. We know 0, 3, and 1, 0 with a dotted line and shading on this side. And the other one was 0, 4, and 2, 0, and negative 1, 6 is where they intersect with a solid line. Now remember how for this red line we tested 0, 0, and 0, 0 was not a solution, which meant I had to shade above. So where does that mean my solution is? Well, the solution is the overlap. It's this region in here. Wow, I've got to be really careful with my graphs for these problems. So again, how did we do this problem? We graphed this inequality, we graphed this inequality, we made sure we had the shading correct on each, but then we looked for points of intersection, and I think we should label that point of intersection on the graph. That's negative 1, positive 6. Okay, we've got a point of intersection labeled there on the graph, and so we know that between these two, we have a solution. Not down here. This isn't going to work. Only up here. To the left of the purple dotted line and to the right of the solid red line is our solution region. Okay, so we've got some stuff to look out for. Let's do our next problem. 2. 3x plus y is less than or equal to 6. Y minus 2x is greater than or equal to negative 1. And y is greater than or equal to negative 2. Here's our system. Now we know for the first inequality, we could make a little t-chart and plug in a 0 for x and get y equals 6. And we could plug in a 0 for y, and when we do 3x equals 6 or x equals 2. So we've got some intercepts for the first inequality. What about the second inequality? Well, the second inequality, if I do the same process, x and y, plugging in a 0 for x, I get y equals negative 1. And if I plug a 0 in for y, negative 2x equals negative 1, so x equals 1/2. Okay, let's see about graphing then. We've got 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Okay, 0, 6, 2, 0. Did you notice that I was making my scale here 1/2? Why? Because I have an x value of 1/2 I need to graph. But first, I need to draw in the solid line connecting these. And which side of that line do I shade on? Does 0, 0 work? 0 plus 0, is that less than 6? Yes, it is. So I shade this way. Okay. Now let's look at graphing the other inequality, which is 0, negative 1, and 1/2, 0. Don't forget to label the points on your graph. This is going to be, again, a solid line. And again, I don't pass through the origin, so I can use 0, 0 and say, is 0 greater than or equal to negative 1? Why, yes, it is. So this is a solution. So anything on this side is a solution. Now, finally, we have this third inequality here. Y is greater than or equal to negative 2. Remember, y equals negative 2 is a horizontal line. And negative 2 is here. And so I want y values that are greater than -2. Well, they all live up here. So where's my overlap? Well, it's an interesting shape. And then it turns this corner and goes this way. Where are my points of intersection? I've got 1, I've got 2. 2 points of intersection to find. Well, this one I know has a y value of -2, and it's where this second inequality is. So if I plug -2 in for y, I get -2x equals 1, or x equals -1/2. So this ordered pair is -1/2, comma, -2. And what about this ordered pair here? That's where these two inequalities intersect. Well, can I find where they intersect? Sure, I can use elimination to do that. 3x plus y equals 6. -2x plus y equals -1. If I subtract one equation for the other, I get 5x equals 7. Now, yeah, look, because I have to do 6 minus a -1. 7. So x equals 7/5. Ew. Well, if x equals 7/5, what's our y value there? Here we have 7/5, but what's our y value? Our y value we could find by plugging this x value into either of these equations. 3 times 7/5 plus y equals 6. Well, I'm going to multiply everything by 5 to clear out that fraction and get 21 plus 5y equals 30. I'll subtract 21 from both sides and get 5y equals 9, and so y equals 9/5. So my ordered pair here is 7/5, comma, 9/5. Okay, there's our graph. How would this problem have been different if instead of y equals -2, it had said x equals -2? Well, instead of this horizontal line here, I would have at -2 a vertical line, x equals -2. And where are the x values that are greater than or equal to -2? They live this way. And so my solution region would be this triangle, bounded on top by the first inequality, bounded on the bottom by the second inequality, and bounded on the left by the third inequality. Okay, so there's our second one. I do want to suggest that this is stuff that we should have actually done in Algebra 1 and been comfortable with in Algebra 2. So let's move on to something more pre-Cali, like x squared plus y squared is less than or equal to 4, and x plus y is greater than or equal to 1. Here's our system of inequalities. The top one is a circle centered at the origin with a radius of 2, and the bottom one is a linear equation with a negative slope and a positive y-intercept. If you're not sure about that, you could always plug in x and y. A 0 for x tells me y equals 1. A 0 for y tells me x equals 1. And so my inequalities then would graph, if we'll do the linear one first, 1 and 1. And I want a solid line. And does 0, 0 work? Is 0 greater than or equal to 1? No, it isn't. So that's a no, which means yes up here. Here, if we plug, let's graph this inequality. I'll graph it in brown. We know it's a circle centered at the origin with a radius of 2. There's our circle. Now, is our solution inside the circle or outside the circle? Well, solid line, Mr. Kukla, because that's less than or equal to. Okay, if we plug 0, 0 in, is 0 less than or equal to 4? Well, it's certainly less than. So there's the region I shade for the circle. And remember, our solution is the overlap. And the overlap is here to here. Again, I'd like you to be in the habit of writing those points of intersection. How can we find them? Well, I don't really want to try and do elimination here because I don't have anything the same. So I think I'm going to use substitution. I'm going to say that x equals 1 minus y from this equation. And I'm going to plug that x value in here. So I'm going to have 1 minus y squared plus y squared equals 4. Don't forget you have to FOIL here, not just apply the exponent. 1 minus 2y plus y squared equals 4. 2y squared minus 2y minus 3 equals 0. All right, so now I'm thinking about the points of intersection. I'm thinking, oh, Mr. Kukla, this sucks because this isn't going to factor. Look, 2y, 3y, 1, and I can't get minus 2 out of this. So what do I have to do? I have to use the quadratic formula. Oh my God, do I really want you to do that? I guess I do. Sorry. I went for something easy to graph, and I forgot that I should also be checking to see how sucky it would be to find the points of intersection. Okay, so let's find those points of intersection with the quadratic formula. I'm going to get, let's see, 2 plus and minus square root 4 minus 4 times 2 times negative 3 all over 2 times 2. That's 8 times 3 is 24. Negative times negative is positive, so I get 28. 2 plus and minus square root of 28 over 4. We can pull a 2 out of the radical and get 2 square root of 7 over 4. We could factor a 2 out of the top and get 1 plus root 7, 1 minus root 7 over 4, and then cancel. So I'm thinking that this y value up here is 1 plus root 7 over 2, and that this y value down here is 1 minus root 7 over 2. But how are we going to find those x values? Well, I could use this. Here it is. It's already solved for x. 1 minus y. Well, it's a Sunday night, and I can imagine that you don't want to play this game, so I'm just going to take 1 minus my y value. 1 minus 1 plus root 7 over 2. And then down here, again, 1 minus root 7 over 2. So those are my two ordered pair solutions for where these curves connect with each other, but this purple shaded sector is my solution. Okay, let's do another one of those. So first, how about x squared is less than or equal to 1 minus y, and x is greater than or equal to 1 plus y. Well, you know, the first thing I think about here is graphing each of these. Actually, the first thing I was thinking about was finding the point of intersection, because if I added these two equations, I'd have x squared plus x equals 2, and the y's would cancel. Or x squared plus x minus 2 equals 0, which factors as x plus 2, x minus 1. And so I know x equals negative 2 and positive 1 are points of intersection. And if x equals negative 2 minus 1 is negative 3 for y. And if x equals 1, and I subtract 1 from both sides, I get y equals 0. So I have my 2 points of intersection, and they weren't so difficult to find. But graphing these might be a little more challenging because they're not in y equals form. Well, if I rewrite the top one so it's in y equals form, I'm going to have y is less than or equal to 1 minus x squared, which is the same, remember, as negative x squared plus 1. Well, that's a downturned parabola, shifted up 1. Solid line. And will we shade inside the parabola or outside the parabola? Well, I'm not sure, so I'm going to test 0, 0. Is 0 less than or equal to 1? Why, yes, it is. So my shading is inside. Now, what about the second inequality? Well, again, I think I would like to solve this for y equals by subtracting 1 from both sides. So x minus 1 is greater than or equal to y. So here I've got a y-intercept of negative 1 and a slope of positive 1, up 1 over 1. Well, remember we talked about one of the points of intersection being 1, 0, and sure enough, both of these pass through that point. I'm going to draw another solid line, and I see a second point of intersection down here. Finding these points of intersection let me know that this line continued and they should intersect down here somewhere. Now, what about my solution? Is it going to be above or below the brown line? Well, if I plug 0, 0 in, 0 is greater than 1 plus 0. No, 0 is not greater than 1 plus 0. So this is not a solution, which means all the solutions are on the other side. And so where's my overlapping region? My overlapping region is here. Okie doke. There was our second pre-Cali inequality to graph. Well, let's do one or two more and then we'll go backwards, okay? How about this one? X squared plus y squared is greater than 1, and x squared plus y squared is less than 4. Well, that's interesting. That's just two circles, one with a radius of 1, the other with a radius of 2. And both with dotted lines. Here's my radius of 1 circle. And where do I shade? Well, if I plug 0, 0 in, is 0 bigger than 1? No, so that's not a solution, which means I shade out like the sun. And then if I graph my second inequality, x squared plus y squared is less than 4, we know the radius is now 2. And we draw in our dotted circle. And where will we shade now? Well, if I plug in a 0, 0, 0 is less than 4. So shading in is a solution here. And remember, our solution to this system is the overlapping region. And so what we're going to get are two circles, two concentric circles that are dotted like that. There's my inequality. Okie doke. Okay. We'll do one last one, and then we'll go backwards. How about y is greater than or equal to x minus 2, and y is less than 4 minus x squared. Notice one of our lines will be solid, and the other will be dotted. You know, I kind of enjoyed 2 problems ago finding the point of intersection first, so I think I'm going to do that again. I think I'm going to subtract the bottom equation from the top, because y minus y will be 0. And then I'll have x. Negative 2 minus 4 is negative 6. And 0 minus x squared is negative x squared. If I move everything onto the other side of the equation, I have x squared minus x plus 6. Ew, Mr. Kukla, no. Did you do it again? I did do it again. I'm sorry. These were so easy to graph. I thought they'd be fine. But now we're going to have to use quadratic formula again. All right. we'll go to graph. You'll see. So x minus 2. We know that means there's negative 2 and positive 2 because we have a slope of 1. And we have a solid line. And if I plug in 0, 0, 0 is bigger than negative 2, so I'm shading up. Now, what about the other inequality? Well, 4 minus x squared has a y-intercept and a vertex at 0, 4, and passes through the point at positive 2, 0, and negative 2, 0. But this is a dotted or dashed parabola. Well, how come 2 is a solution there, but I wasn't getting to a solution here? Well, that's very strange. It kind of makes me want to go back and do the solving a different way. We'll do that in a minute. Okay, so what about the shading for the parabola? Well, if I plug in 0, 0, I get 0 is less than 4. So 0 is a solution on the parabola, which means I'm shading in the parabola and above the purple line. So there's my solution region. It looks like I have one ordered pair at 2, 0. But what about this other ordered pair? Well, let's find out. Y equals x minus 2 and y equals 4 minus x squared. Let's use substitution this time. Where I see y, I'm going to replace with x minus 2. So x minus 2 equals 4 minus x squared. And then I'm going to add x squared to both sides and subtract 4 from both sides. There it was. I had a sign mistake. Equals 0. This does factor as x plus 3, x minus 2, and so I get x equals negative 3 and positive 2. Okay, so this point over here must be negative 3 comma what? Well, if I plug negative 3 into one of the inequalities, negative 3 minus 2 is negative 5. So there are my 2 points of intersection, and there's my shaded region between the purple line, purple solid line, and the dotted brown line. Any questions about going forwards? Oops, I can't take them. I guess you could send them to me. I'd love to have your questions. All right, let's try going backwards now. Now, by going backwards, we're going to start off with a picture, and you're going to write the system of inequalities that goes with it. How about 3, 3, negative 3, negative 3, solid line circle, and then we have a line that passes through 0, 4, and 2, 0, and it's a dotted line, and the shading for our solution is here. All right, well, let's think about this. First of all, we've got our circle. The circle is centered at the origin, and the radius appears to be 3 everywhere. So we know we can write x squared plus y squared and 9. Remember, the equation is x squared plus y squared equals r squared. But what about the inequality symbol? Well, notice we're shading inside the circle, not outside. Well, which one is that? Is that this one? Or is that this one? Let's imagine we don't know. And let's plug in 0, 0, because 0, 0 should be a solution. It's inside the circle. If I plug 0, 0 in, I get 0 is greater than or equal to 9. Is that true? No. What that means is I've guessed the wrong inequality symbol. Let's try the other one. Now when I plug in 0, I get 0 is less than or equal to 9. Is that a true statement? Why, yes, it is. So I know that this is the first inequality. There's the circle. Now, what about the line? Well, the line has a y-intercept of 4, so I know my b value is 4. And what about the slope? I go down 4 and over 2. Slope is rise over run. Down 4 over 2 is negative 2. So I can write then y and negative 2x plus 4. But again, which inequality symbol should I use? Should I use this one? Well, if I plug in 0, 0, I get 0 is less than 0 plus 4. Is 0 less than 4? Why, yes, it is. Huh. But wait a minute. There's something wrong with this. This point isn't in that shaded region. This wouldn't be a solution for the line. Remember, the line goes this way. 0, 0 isn't a solution for the line. That means I didn't guess right. So I need this way. Now if I plug in 0, 0, I get 0 is greater than 0 plus 4. 0 is greater than 4. No, it isn't. That point shouldn't work. Good, it doesn't. And now I shade on the right side of the line. So then my inequality system would be the circle inequality that we came up with, x squared plus y squared is less than or equal to 9, and y is greater than negative 2x plus 4. There we go. Okie doke. So that's going backwards. Let's do one or two more of those, and then we'll call it a day. How about this one? Again, let's have a circle. This time the circle is dotted at negative 4, negative 4, 4, and 4. And let's have a parabola. I think I've drawn that parabola awkwardly. Yeah, let's have that parabola. And then I want to shade here. Oh, I need to give you a second point on the parabola. That's what I need to do. Okay, so let's say I've got the point 2, 4 on my parabola. Okay. Alrighty. Whoops. I guess 2, 4 would have to be slightly slightly like that. Okay, so which do you want to do first, circle or parabola? Well, I think the circle is easier because the circle is centered at the origin. So I'm going to go with x squared plus y squared, and the radius is 4, so remember this needs to be 16. We're shading inside the circle, and we have a dotted line. So I'm going to guess this one this time. 0, 0 is a solution point. If I plug in 0, is 0 less than 16? Yes. So I guessed the inequality direction correctly. Now, what about the other inequality? And that is this parabola. Notice I must be shading on the outside of the parabola for the shading in my solution to be here for overlap. So I want outside the parabola. And I'm thinking about y equals x squared. And I'm thinking about greater than or equal to x squared. And I wonder if there should be an a value there. So if I plug in a 2, 2 squared is, 4a equals 4a equals 1. So I don't have to worry about an a value here. But that's what a second point would be there for. I just have y squared, a y, and x squared. Now, what about the shading? Well, 0, 0 is on the curve this time, so I can't use that. But I can use a point down here, like 0, negative 1. Well, let's plug in 0, negative 1. A 0 for x and a negative 1 for y. Oh, is negative 1 greater than or equal to 0? No, it isn't. So the direction on this inequality is not correct. I need to flip that around like this. Now when I plug in 0, -1, I get 0 is greater than or equal to -1, and that is true. So this is my system. Okay, for our last one, let's do something that just deals with straight lines, but is a little more complicated to look at. Mr. Kukla, stop drawing lines. There you go. So this is y = 3. This is y = 0. This is the origin. This is the point 0, -3. This is 4, 0. And this is 3, 0. And this is 0, 4. And what about our shading? Well, our shading is here. Huh, what an interesting shape. It's a pentagon. 1, 2, 3, 4, 5 sides. So how do we shade for this? Well, I see 5 inequalities. This top line is a boundary. The y-axis is a boundary. The x-axis is a boundary. This line is a boundary. And this dotted line is a boundary. Let's start with the vertical and horizontal lines. So this is y = 3, and I want to be below it. So y is less than or equal to 3. That's the top inequality. The bottom inequality is y is greater than or equal to 0. I want all the y values bigger than 0. Now what about this vertical line? Remember, vertical lines are x equals, and I want the x values that are greater than or equal to 0. So that's 3 of my inequalities. Now, what about these lines? Well, this line has a y-intercept of -3 and a slope, it looks like 1. I go up 3 and over 3. Let's check that. Up 3, over 3. Why, yes, it is a slope of 1. So y, 1x minus 3. But what about the direction of the inequality? Since I'm shading above and to the left of this line, I want 0, 0 to be a solution. If I choose this, is 0, 0 a solution? 0 is greater than 0 minus 3. Why, yes, 0 is greater than -3. So this is my fourth inequality. And then what about this line? Well, this line has a y-intercept of 4 and an x-intercept of 4, which means my slope is down 4 over 4. M equals -4 over 4, or -1. We can see the y-intercept, or b value, is 4. So y equals -1x plus 4. But what about the inequality symbol? Well, will this one work? Now, I'm shading below this line, right? We see all this in order to get this overlapping region. So 0, 0 again is a solution point. If I plug in a 0, is this a true statement? Is 0 greater than 4? No, it isn't. So I've guessed the inequality wrong, and this is my inequality. So I would like you to write up the solution for this one to be y is less than or equal to 3, y is greater than or equal to 0, x is greater than or equal to 0, y is less than -x plus 4, and y is greater than or equal to x minus 3. This would be our system of inequalities. This was a horizontal line, the bottom horizontal line, the left vertical line. This was our top dotted line, and this was our bottom up on a diagonal solid line. So this one down is y is less than or equal to 3. This one up is y is greater than or equal to 0. This one right is x is greater than or equal to 0. And then we had our two dotted lines, our solid line and our dotted line. Okay, so that should be enough for you to be able to take care of the homework. Good luck with that, and send me any questions you have.